Okay, students, so in my earlier video, I have discussed about different types of chemical reactions from class 10 chemistry. We got four types: combination, decomposition, displacement, and double displacement. Now, a new concept has been given, a new type of reactions, which is new to you. So that we'll be discussing here, that is oxidation and reduction reactions. Now, what is oxidation and reduction reaction? Any reactions, we can classify it as oxidation or reduction if either of these things happen. Like a reaction may be oxidation reaction if there is addition of oxygen, and in reduction reaction if there is removal of oxygen. Now this is in terms of oxygen. Similarly, in terms of hydrogen also we can explain. Oxidation is removal of hydrogen, reduction is addition of hydrogen. Now it is not that in every reactions you will get oxygen or hydrogen. There might be reactions where there are no oxygen, there is no hydrogen. So for such reaction, whether it is oxidation or reduction, we describe or try to find out in terms of electrons. So the third criteria is if there is loss of electrons during the reaction, it is called oxidation reaction. If there is reduction, if there is gain of electrons, it is called reduction reaction. Now these are some of the general very simple examples of oxidation reaction, like copper reacting with oxygen. You take some copper filings and you keep on hitting it, soon it will become blackish due to formation of copper oxide. Magnesium ribbon, burning of magnesium ribbon, white color ash like substance will be formed, magnesium oxide. So in both the reaction there is addition of oxygen, so we can directly say it is oxidation reaction. However, let us have a look at this reaction. Copper oxide plus hydrogen, you will end up getting copper and water vapor. So what happens here when we heat copper oxide with hydrogen? We find copper oxide is changing into copper. So there is a case of loss of oxygen. So since it is a case of loss of oxygen, so loss of oxygen or removal of oxygen is what? Reduction. So there is a reduction reaction going on. Hydrogen here is getting changed over to water. So what is getting added to hydrogen? Oxygen is getting added. So it is your gain of oxygen. So gain of oxygen, it is a case of oxidation reaction. Now one more thing we have to know here, that is, now copper oxide is losing oxygen. Who is helping copper oxide to lose this oxygen? It is hydrogen, because hydrogen is taking away this oxygen. So hydrogen is helping in the process of reduction. Therefore, hydrogen is called the reducing agent. Similarly, hydrogen is gaining oxygen. Now, who is helping hydrogen to gain oxygen? It is copper oxide. Copper oxide is giving away oxygen to hydrogen and it is getting converted to water. So this copper oxide is acting as the oxidizing agent. So what is reducing agent? Reducing agent is the substance which will help in the process of reduction, but in the process itself will get oxidized. And similarly, oxidizing agent will help in the process of oxidation, but in the process itself will get reduced. That is the definition. I am repeating once again. Reducing agent is the substance which helps in the process of reduction, but in the process itself gets oxidized. Oxidizing agent is the substance which will help in the process of oxidation, but in the process itself will get reduced. So there are more examples here, like zinc oxide and carbon. So zinc oxide is getting converted to zinc. So there is a loss of oxygen. So it is a case of reduction. Carbon is getting converted into carbon monoxide. So it is gaining oxygen. So it's a case of oxidation. There is undergoing oxidation. So this will act as the reducing agent because it is helping in reduction of zinc oxide, and zinc oxide will act as the oxidizing agent since it is helping in oxidation of your carbon into carbon monoxide. Now you need to understand, okay, I'll explain to that when we'll learn the electronic concept. Here also manganese oxide, another example, manganese oxide plus hydrochloric acid giving you MnCl2, manganese chloride, chlorine and water. So we can say manganese oxide is getting changed to manganese chloride, and HCl is getting converted into Cl2. So manganese oxide getting converted into manganese chloride, so it is a loss of oxygen. Oxygen is getting lost. So it is a case of reduction. Here HCl is getting converted to Cl2, so it is a case of loss of hydrogen. Hydrogen is getting removed. So loss of removal of hydrogen was what? Oxidation. So there is a oxidation reaction. So what is happening here? This is undergoing reduction, so this will act as the oxidizing agent because it is helping the other substance to undergo oxidation. Similarly, hydrochloric acid, this is helping in the process of reduction, so this is the reducing agent. Now such reactions where we find both oxidation and reduction going on, these are called redox reaction. These are called redox reaction. Reduction and oxidation both are going on. So whenever there are such examples given, not only you have to identify what is undergoing oxidation, what is undergoing reduction, but also you need to identify which is the oxidizing agent and which is the reducing agent. Now let us take another example where there is no hydrogen and oxygen involved. Suppose sodium plus chlorine getting converted to sodium chloride. Now we should remember any element in the elemental condition, it is neutral. Now sodium is all alone. When it is all alone, it is neutral. But when it is in a compound form, it is in the form of ion. So in sodium chloride, sodium is in the form of Na plus, chloride is in the form of Cl minus. So what is happening? Sodium, it is neutral, it is getting converted into Na plus. Neutral means what? Total number of protons will be equal to total number of electrons. So sodium neutral, so sodium atomic number is 11, so it will be having 11 protons and 11 electrons. So plus 11 and minus 11, overall neutral. Now it is a metal. You will be getting in metal non-metal chapter, metals are elements which have a tendency to lose electron. So how it will become plus? Now you should remember in any chemical reaction, number of protons never changes because protons are present in the nucleus. What changes is the number of electrons. So only electron numbers will change. So to get the answer as plus 1, plus means plus 1. Protons, I told you, number will remain same. So electrons will become how many? To get the answer as plus 1, electron has to become 10. So plus 11 minus 10. That means from 11 electron, we have got 10 electrons. So it is a case of what? Loss of electron. So electron is being lost. So sodium to sodium positive, it is a case of loss of electron. Loss of electron, if you look at the differences I gave you, loss of electron is a case of oxidation. So sodium undergoes oxidation. Similarly, chlorine, we take the elemental form Cl, it is neutral, it is getting converted into Cl minus. So chlorine atomic number is 17, so 17 proton plus 17, same number of electrons, 17 electrons, so overall neutral. So if the answer has to become minus 1 here, minus means minus 1, proton number never changes, I told you. So electron will become 18. So 17 electron, here there is 18 electrons. So here there is what? Gain of electrons. So gain of electrons, so chlorine changing into Cl negative, it is the case of gain of electrons. So it is a case of reduction. So this is undergoing reduction. So who is helping in reduction process? It is sodium. So this is the reducing agent, because you see metal, sodium is a metal, metals are losing electron. This lost electron will be gained by this. So this is a reducing agent and this substance is the oxidizing agent because it is helping in the process of oxidation. Similar is the case here, zinc plus copper sulfate. It is an example of displacement reaction. So what is basically happening here? You have zinc all alone, so it is in a neutral condition. Here copper sulfate, so copper is in Cu2 plus form, SO4 2 minus form. Zinc sulfate, Zn 2 plus and SO4 2 minus. And copper is neutral here, copper neutral. So zinc It is changing from neutral state to Zn2 plus state. So how it will become positive? By loss of electrons. So there is a case of oxidation. And copper 2 plus, here it is copper 2 plus, it is changing into what? Copper neutral. Copper 2 plus is changing into copper neutral. So positive charge is decreasing, means actually it is due to gain of negative charge, that is gain of electrons. So gain of electrons is the case of reduction reaction. So this is how we can find out oxidation reduction reactions, or which is undergoing oxidation, which is undergoing reduction, if it is in relation to electrons. And at the end of the chapter, so those are the different types of reactions given. In the end of the chapter, they have discussed about examples of oxidation in day-to-day life. One of the example of oxidation is respiration, where glucose is oxidized. You know, in bio you will get in details, glucose is oxidized in the cell, and we get carbon dioxide, water, and chemical energy in the form of ATP. Combustion is another type of oxidation reaction. I told you in my earlier video that all combustion reactions are oxidation or combination reactions, but all combination are not combustion reactions. So combustion means along with all these heat and light will be formed. Heat and light. This you can identify. This is carbon, burning of coal or whatever. This is methane. CH4 is methane. Methane is the most important gas present in natural gas. So it is the main gas of natural gas. Methane, you burn methane, you get carbon dioxide, water plus heat and light. This C4H10, this is your butane. Butane is the most important constituent of petroleum gas, LPG, that you use at home. So when you burn that, the products are same, carbon dioxide and water plus heat and light. Two important examples of oxidation which is given. One is your corrosion. Corrosion, the definition is slow eating away of the metallic surfaces. When metals are, any kind of metal surface is exposed to air, over the time on exposure to oxygen, moisture and other gases in air, the metal surface gets corroded, or it gets very slowly it gets eaten away. So that is called corrosion. So one of the best example of corrosion is rusting of iron. So how iron gets rusted? When iron is exposed to moist air, so it will get oxidized. So Fe, iron plus oxygen plus X, X means any number of water molecules. So it will form hydrated ferric oxide. So there is the scientific name for rust, hydrated ferric oxide. Okay, hydrated ferric oxide. So we know that what is the problem? If you remove the rust, the iron surface will become thinner, and over the time it will go on becoming thinner, and ultimately the object will break. So how can you prevent rusting? Painting, oiling, greasing. Then you can do surfacing, that is called electroplating. All those are the different ways of preventing rusting. So the most cheap way is to do it by painting or putting oil or grease, so that you cut off the supply of oxygen coming in contact with iron. Similarly, copper vessels, when exposed to air for a long time, you must have also copper utensils in your home, they develop a green color coating. Why that green color coating? Because copper will react with carbon dioxide, water and oxygen present in air to form that green color coat, and that green color coat, the chemical name is it is called basic copper carbonate. Basic copper carbonate. So why basic? Because copper hydroxide and copper carbonate. This dot means both are physically attached. One molecule of copper carbonate is physically attached with one molecule of copper hydroxide. So therefore there is a base, so it is called basic copper carbonate. You must have seen that such copper utensils are cleaned with lime or tamarind, because this is a base. So when you are rubbing it with lime or tamarind, it contains acid. So acid and base will react, neutralization reaction, salt will be formed, and it can be washed off. The original shine is restored. Similarly, silver articles, when they are exposed to air for a long time, especially in laboratory conditions, they become black, they develop a blackish layer. Because if there are traces of this gas, hydrogen sulfide, now this is also a colorless gas, let me tell you, identifying feature of this gas is that it has a rotten egg smell. So if these traces of this gas is present in air, then silver will react with this gas and it will form silver sulfide, which forms a black color layer. Next is another example of day-to-day oxidation is rancidity. What is rancidity? Sometimes you must have seen oil, if kept over a long time, or fried peanuts or something, if they are kept open or exposed to air for a long time, they develop a very foul taste or smell, and that is called rancidity. It is the oxidation of the oil present in fried food and all. So those are volatile substances which are formed. So how can we prevent rancidity? One thing is that we can pack with nitrogen. You have seen chips are being packed with some gas. So what is there? Air is not there. There is nitrogen. Now why nitrogen is used? Because nitrogen is an inert gas, not a noble gas, remember, inert. There is a difference between inert and noble. Noble gases are there, those whose outermost shell in the atom, outermost shell is full. But nitrogen is inert. Inert means non-reactive. Why non-reactive? We'll learn later that two atoms of nitrogen, they are bound to each other by 3 bonds, which makes them extremely stable and they easily don't react with other gases. Therefore, the chips packet, they are chips or any other fried packets, they are flushed with or packed with nitrogen so that the rancidity can be prevented. Then vacuum packing, you must have seen some dried fruits or nuts, they are totally, the packet is sticking with the material because all the air has been sucked out. Refrigeration at low temperature also, the rate of oxidation becomes less. Then we can do airtight packing. Then there is another, in industries it is used along with the food material, antioxidants are mixed. Antioxidants like BHA, butylated hydroxyanizole, and this is butylated hydroxytoluene, TOLUENE. These are all organic compounds. They are antioxidants, so they are mixed with the food to prevent the oxidation of the oil. So these are the different examples. So overall, these are the reactions in the first chapter and the examples of oxidation given. If you have any queries, you can get back to me. Do check my other videos based on other topics. Thank you.